Good morning, class. Welcome back to you all after the setup break. So, in the last class, we have completed chapter number 5, heat and temperature, isn't it? We have written the notes as well as we have done the question answers from this chapter. Today, we'll begin a new chapter, chapter number 6, transfer of heat. Okay, so it's on page number 86. So everyone turn your book to page number 86 and get ready with your pencil. All right, so the chapter is chapter number 6 and the heading is transfer of heat. If you see on your page number 87, you'll find this page, and here you have the learning objectives. What are the things that you are going to learn in this chapter? So basically you are going to learn 5 topics here. The first is transfer of heat, how the heat transfers from one object or from one body to another body, or from one portion of a body to the other portion of the same body. Okay, then we'll learn about the 3 types of transfer of heat, or 3 modes or 3 ways in which heat can be transferred. They are conduction, convection and radiation. These are the 3 ways in which heat can transfer. And lastly, we will learn about the thermos flask. Okay, the thermos flask, the flask that you use at home to keep the water hot for a long period of time. All right, so let us now begin with the first topic, that is transfer of heat. Now, what is transfer of heat? You must have observed that when hot tea is poured into a cup, the cup gets warm. Similarly, if you dip a steel spoon into a cup of hot milk or tea, the spoon becomes warm. Isn't it? You have noticed this, isn't it? So when you are have a cup of tea, okay, and you are putting here hot tea here, okay, the entire cup gets warm. Yes, so hot tea is transferring the heat from itself to this cup and making the cup warm. Similarly, if you dip a steel spoon into the hot milk or tea, okay, you have dipped a spoon here, what happens? The spoon also becomes warm. Similarly, when you stand in the sunshine, just like today, it's a very sunny day, isn't it? You will feel warm. So all this happens because heat is getting transferred from the warmer object to the cooler object. In the last chapter, we have learned that heat always gets transferred from hot body to cold body. Heat energy is always transferred, or heat flows from hot body to cold body, and the flow of heat also depends on the temperature, isn't it? Now please underline here, the movement of heat from one body to another is called transfer of heat. So please underline this. Okay, the movement of heat from one body to another is called transfer of heat. So the definition of transfer of heat lies here. Understand? Okay, so now let's continue. Heat is transferred from one body to another by 3 different ways. See, again mark here. So how many ways are there? 3 different ways are there, or we also call them as modes. 3 modes. What are they? Conduction, underline here, convection and radiation. So there are 3 ways or 3 modes in which heat can transfer. Okay, what are they? They are conduction, convection and radiation. So these are the 3 modes, okay, or 3 ways in which heat can transfer from one body to another. Okay, so let us see how this process takes place through the experiment given below. So you can go through this experiment number 1. Okay, experiment number 1 is your homework. Go through it. Okay, just below this figure you will find on your book on page number 86 there is an experiment. So here you have figure number 6.1 where the modes of transfer of heat, there is 3 ways is given. 1, see, you have a rod, a person is holding the rod here, so the heat from the fire is heating up this rod. okay, and the heat is getting transferred through the rod to the hand. The person who is holding the rod, you'll feel hot, okay, at the end here. This way of transfer of heat is called conduction. So here you see heat is hot, or you can say hot air, okay, the air which is getting hot due to the fire is rising up. So this mode of transfer of heat is called convection, and ultimately it is the third one is the radiation. So we'll be learning them one by one. Okay, the three modes of transfer of heat, what are they? Conduction, convection, and radiation. So now let's begin with the first mode, that is conduction. So on page number 87 you will find this topic, conduction. Now when one end of a metal rod, say an iron rod, is held in hand, the other end is heated, the holding end of the rod soon becomes warmer and warmer, due to which the person holding it is unable to hold it. Why does this happen? This happens due to the transfer of heat energy between the different parts of the body, or from one body to another in contact with it. Thus transfer of energy between different parts of body or from one body to another is in contact. See, it should be in contact, is called conduction. Okay, so if you have a metal rod, suppose say this is my metal rod, okay, I'm holding from this end, and this is the end where I am hitting it. So this is my candle, I'm hitting the iron rod at this end, and I'm holding at this end. So I'm holding the iron rod at this end, and here I have the fire which is hitting the rod. Understand? So after some time, what will happen? Heat energy from this end A, I can write end A and end B. End A, heat energy from end A will be slowly flowing towards end B. Understand? Now how does this happen? See, conduction is the process of transfer in solids only. See, conduction can take place only in solids. So you can put a star mark here. In solids, the molecules are packed closely together. When one end of the solid is heated, the molecules absorb the heat energy and begin to vibrate rapidly. Understand? They begin to vibrate rapidly. These molecules in turn cause their neighboring molecules to vibrate. This process is continued along the iron rod, and energy is transferred from hot part to the cold part of the solid. So here so when I'm heating here at this end becomes hot, whereas this end B is still at cold, and heat energy flows from hot body to cold body. Now how does this happen is that every matter is composed of tiny particles called molecules. So here these are the molecules. In solids, these molecules are very, very closely packed. So here I'm drawing very few molecules, okay, but remember there will be millions and millions of molecules at in this iron rod, okay. But to make you all understand easy, okay, in an easy way, I'm drawing few molecules to just make you all understand that how energy is getting transferred. So what happens here is that the first molecules will observe the heat energy and will start to vibrate more vigorously, more rapidly. Vibrate once. So when it's vibrating, it transfers energy to the next molecule. Now this molecule starts to vibrate. Understand? Now when this molecule has started to vibrate, what happens? It transfers energy to the next molecule, and the next molecule will start to vibrate, and in doing so, in turn, what will happen? It will transfer the energy to the next molecule, to the next, and ultimately it will reach to the other end, that is end B, and the person who is holding this rod will not be able to hold the rod further, because now the entire rods get heated up. So that is why we say that conduction can take place only in case of solids, because in solids the molecules are closely packed. Molecules cannot move from one place to another. Molecules cannot change their place, and hence it can just vibrate in their mean position and transfer the energy from one molecule, or you can say from hotter molecule to the colder molecule, and this is how the energy is getting transferred from one end to the other end. So in the process of transfer of heat energy from one molecule to another molecule is what we call conduction. यसलाई चाहिँ हामीले भन्छौँ conduction, the first mode of transfer of heat, and conduction can take place only in solids. Please remember this. Okay, now the rate at which the heat energy is conducted is known as conductivity. So please underline this. What is conductivity? Conductivity is the rate at which heat is conducted is known as conductivity. The conduction of heat stops once two bodies attain the same temperature. So when two bodies, see, conduction will take place in two different bodies, but two different bodies should be in contact with each other. It should be in contact with each other. Then only the heat energy will transfer from one body to another body by the process of conduction. Okay, for example, when the bulb of a thermometer is brought in contact with a hot body, the mercury absorbs the heat and its level rises. Once the thermometer and the body are at the same temperature, no further heat is transferred and the mercury level does not rise. So what happens if in this case, if A is hot body and B is cold body, I have brought them in contact with each other. Okay, energy will flow from A to B. Okay, but the flow of energy will stop when both of these body are at same temperature. Temperature same छ भने चाहिँ heat energy will stop to flow, because in the last chapter I taught you that the flow of heat depends on the temperature of the two bodies, not in the amount of energy contained in the body. All right. Okay, so now let's go to the next topic, that is good conductors of heat, which you will find on page number 87 itself. Here we have good conductors of heat. So the substances, please underline, through which heat is easily conducted or in which the rate of conduction is high, okay, are called good conductors of heat energy. Means those bodies, okay, or those substances which can easily, okay, through which heat can easily pass or heat can easily flow is called good conductors. What are the examples? All metals like silver, copper, aluminium, iron, etc. are good conductors of heat. Please underline this. Different substances conduct heat at different rates. So good conductors are those conductors or those substances which allow the flow of heat energy easily. Understand? Now what are bad conductors? The substances, please underline, which do not conduct heat easily. See, do not conduct heat energy easily, or in which the rate of conduction is low, isn't it? But here you see the rate of conduction was high. Where? In good conductors. In bad conductors, the rate of conduction is low, and they are called as bad conductors or insulators. So bad conductors, you have another name called insulators. What do we call it? Insulators. Materials like wood, these are the examples: wool, felt, leather, asbestos, paper, plastic, etc. are the bad conductors of heat. All right. Now, conduction of heat through liquids. Generally, liquids except mercury and molten metals are bad conductors of heat. See, pure water is also a poor conductor of heat. Remember, most of the liquids are bad conductors, but there is an exception. What are they? Mercury, symbol of mercury is Hg, mercury and molten metals. You know, metals are good conductors of heat. So when metals are melted, they will also be a good conductors of heat. So except mercury. You know, mercury is the metal which is liquid at the room temperature. So mercury is also a metal. So except metals, the metals which are in the liquid state, that is molten metals, except them, all other liquids are bad conductors of heat energy. Is it understood here? Okay. Okay, now we will see application of good and bad conductors of heat, means uses. Okay, how the bad conductors and good conductors are useful to us. So cooking utensils and boilers are made of good conducting materials like copper, aluminium, iron, etc. Because why? You know, they conduct heat energy easily. So that is why heating utensils, because when you are cooking food, the cooking utensils must conduct heat energy so that it can supply the heat energy from the gas flame, isn't it, to the food. Yes, so cooking utensils and the boilers means in which we boil the water, they must be made up of good conductors of heat. All right. Cooking utensils are provided with wooden or ebonite handles. Okay, so that heat energy from the vessel does not get conducted to our hand, because when we are lifting up the cooking utensils while cooking the food, the handles we lift them through the handles. So these handles should be made up of wooden or ebonite because they are bad conductors of heat energy. All right. Wool, air are bad conductors of heat. Therefore, in winter, we wear woolen clothes as they restrict the heat conduction from our body to the surroundings and thus keep us warm. Because woolen clothes contain pores in them. These pores, okay, machine dulo huncha. Okay, these pores contain air, and air is a bad conductor of what? Heat energy. Understand? So that is why woolen clothes keeps us warm in the winters. That is why we wear woolen clothes in the winter to keep our body warm. All right. Similarly, thermocol. You have seen thermocol, isn't it? Is used as an insulating material to maintain the temperature of the substances kept in ice boxes. So you have seen the ice boxes, or the person who sells the ice cream, they have a big container, and the inner lining of this container is covered with thermocol. And because thermocol is a bad conductor of heat energy, they are insulators. Understand? So that is why it can keep the ice cream or ice cubes, okay, solid or in the form of ice for a long period of time. Okay, thermocol is another example of insulator or bad conductors of heat. Hot water storage tank and steam pipes are lined with cloth. लाइन भनेको चाहिँ यो ट्याङ्कलाई पाइप्सलाई चाहिँ केले कभर गरेको हुँदो रहेछ? क्लोथ, लुगा, or fiberglass or asbestos or wool. Why? To prevent them, okay, from the loss of heat from water to the surroundings. So this is how, okay, as per our need, we can use the good conductors and the bad conductors or insulators accordingly. Understand? Okay. Now conditions for conduction of heat. So there are three conditions. Bodies should be in thermal contact. Conduction or the transfer of heat through conduction will take place only when two bodies are in contact. Number one. Number two, the temperature should be different. If the two bodies are at same temperature, the heat energy will not flow, because temperature tells you in which direction the heat energy will flow. And every time the heat energy flows from the body which is at a higher temperature to the body which is at a lower temperature. And number three, conduction of heat is not possible in a vacuum. That is, there should be medium for the heat to be conducted. Means you need something which we call as medium, okay, for the transfer of heat in the process of conduction. So conduction must say you always need a medium. So that is why conduction cannot take place in vacuum. All right. So today we learnt about transfer of heat. The flow of heat energy from one body to another is called transfer of heat. Transfer of heat can take place or in the three ways. Okay, they are conduction, convection, and radiation. Today we learnt about conduction, isn't it? The process in which the heat energy transfers from one body to another body, okay, in contact with each other is called conduction. Conduction can take place only in solids. Okay, we learned about good conductors and bad conductors, isn't it? The substances which allow energy to flow through them easily is called good conductors. Examples are all metals like copper, aluminium, iron. Okay, and the substances which does not allow the flow of heat through them easily are called bad conductors. Bad conductors are also called as insulators. Okay, examples of bad conductors are wood, glass, paper, plastic, cloth. Okay, they are all bad conductors of heat because heat cannot flow through them easily. Understand? And you know that all liquids are bad conductors of heat energy except mercury and molten metals. Mercury is also a metal, but it is in the liquid state at room temperature. And you know metals are good conductors of electricity. That is why whether metals are in solid state or in liquid state, they will conduct heat energy. So exception in liquid is that mercury and molten metals, except them all other liquids are bad conductors of heat energy, or you can tell them as insulators. Okay, now there are three conditions for conduction to take place. Conduction can take place only when these three conditions are fulfilled. What are they? They are the two bodies, okay, in which you want the flow of heat energy or the transfer of heat energy must be in thermal contact, means they should be in physical contact with each other. Number two, the temperatures should be different in these two bodies so that heat energy can flow. And number three, conduction of heat is not possible in vacuum, means conduction cannot take place in vacuum. So these are the things that we have learnt. Okay, in the next class we will be learning about convection. Okay, and today you'll be getting the notes based on today's this video lecture. Copy it properly, understand, and learn them. Okay, so that's all for today. Thank you, class.